So let's do another example. This time we're not going to be given the equations, but we're going to have to figure them out. We're going to find the solution and then interpret what it means. Again, what does the solution mean? What are you looking for when you're finding the solution?
Point of intersection.
The point of intersection. Yes. Say it with conviction.
The
Point of intersection.
Okay. So two sisters, Nadia and Lucia, are saving money. Go. You go, girls. Okay? Good idea. They are doing the weird thing where they're saving into an account that doesn't give them any interest. Usually with a savings plan you want to get some interest, but whatever. This is the mattress stuffing saving plan where you just take money every week, I think? Or every day? Yeah, every day. And you stick some money in your mattress every day to hide it away. Okay? How many of you have saving plans?
I think I do.
Okay,
Somewhere.
most of you.
It's hidden.
Good.
Yeah, it's hidden from us.
Hidden saving plans are good, so you can't touch them.
Yeah.
Anyway, so Nadia has already $16. Okay?
Oh.
She has a job, she gets some money, but right now she has $16 total saved. Her sister has $34 already saved.
That's it?
That's it. Hey,
Yeah, that's pretty good.
they're like in grade 4, okay?
Oh,
Give them a break.
Okay.
Okay. They both have part-time jobs where they work together. Each day,
In grade 4?
yes, grade 4. Okay? Grading papers for their dad. Because their dad's a teacher.
Is this what you're going to make your kids do?
Oh, yeah. Okay? So Nadia, every day after work, she goes home, right? Gives her dad a kiss and says, I love you, Daddy. Thank you for making money for us. What you should all do for your daddies. Okay? She takes $5, stuffs it in her mattress, and just keeps it away for a car that she wants to own one day. Lucia doesn't save as much money. She saves only $2 every day. Okay? The girls want to know if they'll ever have the same amount of money. Okay? And if so, on what day will that be? You get the idea?
Yes.
Do they have the same amount of savings in the beginning?
No.
No, they don't. Right? Nadia has 16, Lucia has 34. Could they possibly have the same amount of money one day?
Yeah.
How do you know that?
We have the graph.
Because they're both even.
Because they're not adding.
Like Nadia starts with less money than Lucia. Will she ever catch up?
Maybe.
Maybe.
She saves more money.
Exactly. Nadia is saving more money. So already we know she'll probably one day have more money than her sister. The question is really, will they ever have the exact same amount of money? Because this girl, Nadia, she's adding $5 every day, and Lucia is adding $2 every day. So it's not for certain that they'll get exactly the same amount one day, but possibly. Right? And we can figure that out by creating a system of equations. So what we're going to do is we're going to model each girl's saving amount. Okay? I used the letter A for that. As a function of the number of days that have gone by. Okay? So let's create an equation for Nadia. Okay? Her savings amount, A, is created how?
16 plus 5 times the number of days.
16 plus 5 times the number of days, or D. Alright, so there's one equation talking specifically about Nadia's savings. Lucia would be A equals, what do you think?
34 plus 2.
Yeah, $34 to start out with, plus 2 times the number of days that have gone by, or $2 per day. Right? You recognize both of these as linear equations. In the first one, the slope is... Oh man, come on. Nope. 5, right? It's the number in front of the variable. Okay. Really? You just did a whole chapter on this.
We have it backwards though.
So?
So that doesn't mean anything?
No?
The weekend was rough.
Obviously.
Yeah, it was a rough weekend.
Okay, this is a rate of change, right? This is the amount of money that she gains every day. 16 is her initial rate. Or the...
Y-intercept.
Thank you. Phew. Okay, so we're going to solve the system graphically. Again, this is an important word, solve. What specific points are we looking for when we're solving a system?
Intersection.
The intersection points. Okay, so let's graph those two lines and find the intersection point. Okay, so let's graph these two. We had 16 plus 5d, but we have to use x because that's the only variable your calculator likes in y equals. And 34 plus 2x for the other girl. Okay, we need an appropriate window settings. Okay, so x is the number of days. The minimum would definitely be 0, right? Because you can't have negative number of days. How long should we make this go on for? How many days do you think it would take for her sister to catch up? 9? 6? Let's just put it to 15, just to give them lots of room. Okay? Y is the savings amount. We're going to put the bottom at 0. And how much do you think their savings will be after about 15 days? Let's take a guess. $100 maybe. That might be a little high, but let's see. Okay, graph it. Okay, that's not bad. So here's our intersection point. Again, we don't want to like use our cursor and kind of estimate, although that's kind of good to get a gut feeling as to what that number should be. But we want the exact value. Okay, so again, to find that, we press, what's the first button? Second, then trace, then 5, and then enter, enter, enter. Boom, right there.
What? 6.
6,
Why is it 6?
46. So after 6 days, each girl has $46.
Oh, I see. Because you gotta put on
Get that?
extra amount. Yeah.
So on the 6th day,
Okay.
that's when they have the exact same amount of money. Okay? So 646 was our intersection point. This means on the 6th day, both girls have the same amount of money. That's what that point means in context of the problem. It's the point at which both graphs are the same, or their savings amount is the same. Okay, so let's see if we can solve this system using a table. Alright, so we're going to make a table for Nadia's savings. We're going to start her off at day 0, or she's worked 0 days. And then 1 day, 2 days, 3, 4, 5, 6, 7, and 8. And how much money does she have after working that many days? Well, after she's worked 0 days, she's saved ahead of time $16, but she hasn't made any money yet, so she hasn't saved any extra money. So she just has $16. Then she works 1 day, so she stuffs away an extra $5, bringing her total to 21. Second day of work goes by, adds another $5 to 26, and so on. Just adding $5 every time. And Lucia, again, we're going to go 0 to 8. She starts her savings off at $34, and she adds $2 every day. So this becomes 36 after working the first day, 38, 40, 42, 44, just adding 2 every time. And you can see already our solution here, 646, popping up in both tables. You can see it in the left table right here, and in the right table right here, right? So from our tables, we can tell what the solution is because both of these graphs share the same value. That would be the solution to our system, is when both relations equal or share the same point. Okay, so that just further verifies the solution that we got in B.